Now for part A, we want to determine probability of x equals to, I hope I am on. Yeah, I am on. Probability of x equals to y equals 3. Roman 1. Probability of x equals to y equals 3. So we go to the distribution has already been defined in this table. So x equals 2, y is 3. Where is x equals 2? Here. Because these are the x values. X equals 2 is there, y equals 3 is here. Yeah. So when you correspond y equals 3 to x equals 2, you realize that you get 0.1. Therefore, this is simply 0.1. As simple as that. Then, I think I have to increase on the thickness. Yeah. Part 2, we want to determine the probability that x is at least 2 and y is at most 2. Note that x is taking on values from 1 to 3. That is if at all I'm not mistaken. X is taking on values 1, 2, up to 3. Then y is taking on values 1, 2, 3, 4. Now, x greater or equal to 2, we are interested in 2 and 3. Y less or equal to 2, then we are interested in those values. Therefore, we cater, those are what? I don't know. I think they are around 4 cases of consideration. Now we have the case where we have probability of x when x is 2 and also when y is 1. In simple terms, after extracting them out, these are the values which we are having. So you consider x is 2, y is 1, plus x is 2, y is 2. You do the same thing for x equals 3. X equals 3, y is 1. X equals 3, y is 2. As simple as that. Then plus probability of x equals 3. No. Before that, there is x equals 2. There's x equals 2. Y is 1. Then x is 2. Y is 2 plus probability of x equals 3. Y is 1 plus probability of x equals 3. Y is 2. Colleagues, we have to substitute x is 2, y is 1. What is that value? X is 2, y is 1. X is 2 is here. Y is 1 is also here. When you correspond, there is a 0.3 there. So therefore, substitute 0.3 plus x is 2, y is 2. X is 2 is here. X is 2 is here. Y is 2 is also there up. Corresponding the 2, you realize that there is a 0. There is a 0 there. Plus a 0. Then plus x is 3. Y is 1. X is 3. X is 3. Y is 1. X is 3 is here. Y is 1 is also there up. Corresponding the 2, there is a 0 there. There's a 0. Then plus what is it? That has been x is 3, y is 1. Yeah, x is 3, y is 1. Finally, x is 3, y is 2. X is 3, y is 2. X is 3 is here, y is 2 is there up. So when you correspond, there is a 0.3. This is 0.2. Oh, no. It is 0.2, sorry. And adding, we get 0.5. As simple as that. Then, what? Part 3, probability of y equals 3. Part 3, the probability of y equals 3. Now, in this case, y is fixed. Y is 3. Remember, y was taking values 1, 2, 3, and 4. Now they are choosing one value, y3, y equals 3. So meaning that here we look at it. Remember, this is joining. Even if y is fixed, y is still considered joined with x. Therefore, x is still 1, 2, and 3. X is still varying, but y has been fixed 3. Therefore, to obtain that probability, you pair x equals 1 with y3, x equals 2 with y3, x equals 3, y3. Therefore, probability of y equals 3 is equal to probability of x equals 1, y equals 3, plus probability of x equals 2, y equals 3, plus probability of x equals 3, y equals 3. Colleagues, I want to tell you that x equals 1, y equals 3 from the table. X equals 1 and y equals 3. X equals 1, x equals 1 is here, x equals 1 is here, and y is 3 is also here. Corresponding the two, hope you realize that we get 0.1 for that case. So for that case, you have 0.1 plus c, x equals 2, y is 3, x equals 2, x equals 2 is here, y is 3 is also there up. Corresponding the 2, x equals 2, y is 3, corresponding the 2, there is a 0.1, there is a 0.1, then plus x is 3, y is 3, x is 3, y is 3, corresponding both of them there, to obtain 0. So this is 0. This is a 0. And the summing all that information, you get 0.2. So that is for part Roman. That is for Roman 3. Now for Roman, for part B, for part B, colleagues, what do we want to prove for part B? What have I? Sorry. I want to create a page here. This thing is here, going to this. Insert blank page. Undo. Okay. I think for this I have to grab it off. Or B, not B. Part B, for part B, what do we want to show? For part B, we want to show that here is part B. Show that the sum over all x and y values is a 1. So we sum sum over all x and over all y, f of x, y, we show that this is a 1. Now what is x? X is, I've said it severally, x is that. Then y is taking values 1, 2, 3, and 4. So we sum over all x and y values. In simple terms, we get the total probability which was given in a table. Sum all those things and convince yourself that it is a 1. And how do we define that if you want to see it in a technical way? So to sum, x is, you see, x is a 1. So when x is 1 and y is valid, what is that? That is probability when x is 1 plus probability when x is 1 plus probability when x is 1 plus probability when x is 1. But x is 1 when y is 1. X is 1 when y is 2. X is 1 when y is 3. X is 1 when y is 4. Now that is for x equals 1. Plus, when x is 2, plus, when x is 2, plus, when x is 2, plus, when x is 2. Colleagues, x is 2 when y is a 1, when y is a 2, when y is a 3, when y is a 4. Finally, there is also probability of x is a 3 when y is 1, probability when x is a 3 when y is 2, probability when x is 3 when y is 3, probability when x is 3 when y is a 4. In the next session, I think I